Hey there, Year 11s. Apologies that I could not be there for you for this Monday. I've made a video tutorial for exercise 14K Pythagorean Identity. Hopefully you have received a 14K worksheet or board note for you to fill out, and you'll just go ahead and copy what I do on this video. The learning goals for this lesson is to look into the link between Pythagoras' theorem and any trigonometric identities we have been exposed to, namely sine, cos, and tan. And the success criteria, so what you'll be able to learn or demonstrate or showcase by the end of this is to solve for a trigonometric identity using Pythagoras' theorem. So the Pythagorean identity, what we are doing is we're looking into the a squared plus b squared is equal to c squared identity. This has to do with the right angle triangle, and if you have been given a b lengths, you can find out what c is using this identity, using this formula. But what we're going to do is we're going to relate it to the trigonometric identities we have here that have been established through this unit circle. What we have done here is we've used this as our template formula. So OP, this being O, this being P, this is saying if you get OP squared, this is equal to getting OM squared and adding MP squared. So effectively, it's the same as A and B, but we've just used these points to determine what the line length representation is. But we already know what OM and MP are. That's cos theta and sine theta respectively. So what we can say is that cos theta squared, so cos theta all of that squared, the sine theta all of that squared is equal to 1 squared, which is the hypotenuse, and 1 squared is effectively 1. So this here is our identity, Pythagorean identity, which we've written here. Now there's just a little side note that cos and sine, I'll just use cos as our example, all of cos theta, all of this squared, the shorthand notation that we use, not shorthand notation, but rather the correct convention that we use is this, or whatever variable you decide to do, or something like that. The reason why we do this, there's no distinct reason that has been provided to me. I did ask my teacher when I was in school, and she said that the reason why this has been used, from her understanding, is that while students use this, they got out of the habit of using brackets, and eventually started writing this, and this, and this are not equal, because what you're doing is you're just squaring theta, you're not squaring the whole identity itself. So these two things are not equal, and so it was just easier to say, okay, well, let's just put the squared with the cos or with the sine, so we can show you that this is actually the whole thing being squared. So if it does look confusing, that's okay. It's just to get out of the habit. But if you do see this, effectively it's the same thing, but this is just the more general convention. Alright, so now we know that cos squared theta plus sine squared theta is equal to 1 squared, or 1. We're going to use this trigonometric Pythagorean identity with our trigonometric identities to solve a question that looks like this. So what we are doing is we are going to find cos of x and tan of x, given that the sine of x is equal to 3 over 5, and this x, this angle, whether it be radians or degrees, is in between pi and 2 and pi. So firstly, let's figure out which quadrant this is in. Pi and 2 being here, and pi being here. We are in quadrant 2. The only identities that are positive in quadrant 2, you remember our little acronym, 4 stations to cranny, only sine will be considered positive. Because we are looking for cos, we know that regardless of what solution we get, we need to have this as a negative. So First thing we do is we are going to write this trigonometric Pythagorean, I always say trigonometric, Pythagorean identity here, but instead of using theta, I'm just going to use x because the question has been given as x. So cos squared x plus sine squared x is equal to 1. Now cos x is what we're ultimately trying to look for, and sine squared x, well, sine x specifically has been given to us as 3 over 5. So what we're going to do is we're going to do a straightforward substitution for sine of x, but we just got to remember that this whole thing is being squared. So what we are finding is whatever this is equal to, 3 over 5, all of that squared, and this is equal to 1. Alright, now what we have got left is just one variable, which is x. Let's just first algebraically work out what we can, or arithmetically what we can. 3 over 5, all of this squared. Remember our index laws, that power gets associated to the numerator and the denominator. This is equal to 1. Algebraically, we are going to subtract 9 over 25 from both sides. So this is going to equal 25 over 25, so that's our 1. Subtract 9 over 25. I did this because 25 over 25 is the same as 1. We want our denominators to be the same. Generally, you can go from this step straight to this step here, but if you struggle with your fractions, you're more than welcome to do this. 25 take 9 is 16 over 25. So now we're in a point where we look at this, and because this thing is being, all of this is being squared, we can square root both sides. So this will imply that cos of x is equal to the square root of 16 over 25, which is plus minus 4 over 5. Because when you're square rooting, you're squaring the whole thing, and we can separate that square root on the numerator and the denominator. So cos x is equal to plus or minus 4 over 5. But again, we've already established that because we're in the second quadrant, only sign can be positive. Therefore, cos of x has to be negative 4 over 5. Okay, now that's the first question, A. B, we are looking for tan of x. Now tan of x, you've got to remember that tan of x is equal to sine of x, and we've already seen this before, over cos of x. Because tan of x is opposite over adjacent. Our opposite has already been established as sine x, and adjacent has already been established as cos of x based on the theta position. So what we are going to do is to find out tan of x. Tan of x is effectively just going to be what sine of x is, which is 3 over 5 divided by what cos of x is, which we've already figured out to be minus 4 and 5. And all we have to do is our simple keep change flip, because we're dividing a fraction. So this is equal to 3 over 5 times negative 5 over 4. Now in this case, our 5's here cancel to 1, and what we are effectively left with is negative 3 on 4, or negative 3 quarters. Now, just to make sure that this is correct, tan, it's being in the second quadrant, tan is negative in the second quadrant, so this checks out. So that's all there is to this particular exercise. Please check the bottom of the sheet to see which questions you need to do. It's also in the lesson plan within Compass. Once you've completed that, you've also got some revision questions that you need to complete in preparation for our SAC, which will be the Thursday that's coming up within the week. So best of luck with this exercise, and also best of luck with the chapter review. I will be back at school on Tuesday helping you guys out with any of the questions prior and the chapter review questions. Until then, see you guys soon. Bye.